In this video, I'm going to be focusing on how to balance a chemical reaction in acidic and basic solutions. And so these balancing equations become a little bit different than they were back in Gen Chem 1, mainly because you're essentially missing some pieces. And by that I mean some of these atoms appear on one side that they don't appear on the other side. In addition to that, your charges are not balanced. Your charges are all thrown off. For example, if you look at this practice problem I have, Cr2O7 with the 2 minus has a 2 minus charge. Your HNO2 is going to be neutral, so it has no charge. That means that on your reactant side, you have an overall 2 minus charge. But on the product side, you're looking at Cr3 plus and an NO3 minus. And so there, a 3 plus and a 1 minus will give you an overall 2 plus charge. And so essentially the way that this reaction is written, you're saying that you went from a 2 negative to a 2 plus without really any transfer of electrons, which we know doesn't quite happen that way. And a little bit more easier to notice is on the left side of that arrow, we have a hydrogen. On the right side of that arrow, we have no hydrogen, which more intensely you need to understand that you cannot make a hydrogen out of nothing. They have to show up from somewhere. And so in order to balance out this reaction, the first thing you're going to do is to split it into its half reactions. And what I mean by that is use the common use the common elements on both sides in order to split this single reaction in two. And so for instance, here we know that we have Cr2O7 on one side and we have a Cr3 plus on the other side. And so we know that's the only way that you can have a chromium become a chromium is if something happens to that chromium. Similar to that, we have HNO2 on the reactant side and NO3 minus on the product side. That nitrogen has to be some type of relationship there, so split them up accordingly. And so you can split it up and say that your Cr2O7 2 minus is going to convert somehow into the Cr3 plus. Similarly, your HNO2 is going to be converted into this NO3 minus. And so the first step of these balancing equations is very similar like it was in Gen Chem 1, is balance your non-hydrogens and your non-oxygens. So anything else that is not an H or an O needs to be balanced first. And so if we look at our red reaction here, our chromiums on the left side we have 2, on the right side we have 1. So we can fix that very easily by putting a 2 in front of our Cr3 plus. The next thing you're going to do is balance your oxygens by adding a water to the opposite side. And so in the first here we have Cr2O7, meaning we have 7 oxygens. And so we need to counteract those 7 oxygens, or we need to again balance those oxygens by adding 7 waters to the right side of that chemical reaction. Additionally, in the bottom reaction, we have 2 oxygens on the left side and 3 oxygens on the right side. And so in order to have a total of 3 oxygens on both sides, we need to add 1 water to that HNO2 or that reactant side. And so here again, you're going to add waters to balance out the oxygens. So now in that first reaction we have O7, and on the right side we have 7 O's. In the second one we have 1 H2O and 1 NO2, or 3 oxygens. On the right side we have our 3 oxygens and our NO3. And so the next thing you have to pay attention to is our hydrogens are balanced, but in addition to hydrogen, when you added water, you also added, in addition to oxygen, whenever you went through, you also added hydrogens. And so in order to balance out hydrogens, you add your H pluses to the opposite side. And so in our first reaction, we have 7 waters. And so when you cancel out those 7 times 2 hydrogens, or 14 hydrogens on the right side, by adding 14 H pluses on the left side. And the same deal with the one below it. We have 2 hydrogens coming from your H2O. We have 1 hydrogen coming from the HNO2, but there is no hydrogen in your NO3 minus. And so in order to balance out the hydrogens, you're going to add 3 H pluses on the product side. And so last but not least, the most important thing here, as far as electrons are going for your batteries, is you need to make sure that your charges are balanced. In order to balance your charges, you add electrons to whatever side is needed in order to make the charges equal. Remember, you can't just go through and start adding plus signs and negative signs just because you need them. They need to come from somewhere. And so in this issue, when we kind of look at the first one, we have a 2 times 3 plus on that right side. Or again, 2 of your chromium 3 pluses. Because of that, we have a 6 plus on the right side total. On the left side, we have 14 H pluses and 1 2 minus. And so if you add those two together, we have a 12 plus on the left side. And so if we have a 12 plus on the left side and a 6 plus on the right side, we need to add 6 electrons as reactants in order to, again, make sure that everything on the left side is 6 plus and everything on the right side is 6 plus. Very similar to the one below it, H2O, it's neutral, it has no charge. HNO2, neutral, has no charge. And so the only side that does have charges is going to be your -1 coming from the NO3 and your +1 coming from 3 of your hydrogens. And so if you have 3 plus and 1 minus, then we know that we need to add 2 electrons on the product side to make it equal to 0. So here we're looking at a chromium 3 plus being canceled out with your 6 electrons. We're looking at your NO3 minus and your 3H plus being canceled out with those 2 electrons. And so the last step that we have to kind of take into consideration before we actually start throwing all this stuff together is this doesn't work. And the main reason is, again, going back to Gen Chem 1 and thinking about those cascade reactions, or again the stepwise reactions, you can only add these two equations together if you have a common factor that is balanced. And in these cases, the H pluses aren't going to be balanced. It's going to take forever to do that. And so the easiest way we can balance something is to use the electrons. And so in the upper equation, we have 6 electrons. In the second equation, we have 2 electrons. In order to fix that, let's just multiply everything in the bottom equation by 3, and you end up with your 6 electrons, again, along with everything else being multiplied by 3 as well. And now this equation is ready to be added to one another. And so here you can have, again, just showing you all the reactants, you have your 6 electrons plus your 14 protons plus your 1 Cr2O7 2 minus, all that coming from the first reaction. Then you have 3 H2Os and 3 HNO2s coming from the second reaction, keeping in mind that you need to multiply both of those by 3 in order to kind of, again, keep everything straight here. On the product side, you have your 2 Cr3 pluses, you have your 7 H2Os, and again, 3 of your NO3 minuses, 9 H pluses, and 6 electrons. The main reason why we are doing this and why we want our electrons to be equal instead of our hydrogens is because you normally don't want to see electrons when you're writing out these balanced chemical equations. And so now that we have 6 electrons on the left side and 6 electrons on the right side, we can cancel our electrons out. In addition to that, if we have common things or common units on both sides of this equation, we can cancel those out as well. And so looking at our H pluses, we have 14 H pluses on the left side, and we have 9 H pluses on the right. And so what we can do is 9 of those H pluses will cancel out from both sides. But remember, you cannot just completely destroy 5 H pluses that have no reason to be gone. And so that 14, not all of them go away, you're still left with 5 H pluses on the reactant side. Your Cr2O7 2 minus, there's not much you can do with that because it has to be there. But the waters, on the left side you have 3 waters, on the right side you have 4 waters. And so 3 of those waters on both sides can cancel out. And so your 3H2O will cancel completely out, and your 7 waters will now become 4 waters. And the last thing you have to do for this particular problem is just throw it all into a nice convenient looking reaction. And so we end up with 5H plus aqueous plus Cr2O7 2 minus aqueous plus 3HNO2 aqueous becomes 2 Cr3 plus aqueous plus 3NO3 minus aqueous plus 4H2O, not aqueous but liquid water. And so the whole idea here is additionally go through and just make sure that everything is balanced the way it needs to be. And so for this one, we have 5 H's plus our 3 HNO2s. And so we have 8 hydrogens on the left side, 8 on the right side. We have 2 CRs on the left side. We have 2 CR3 pluses on the right side. We have 7 oxygens plus our 6 oxygens. And so we have 13 oxygens on the left. On the right side, we have 3 times or 3, so 9 oxygens plus 4 oxygens, so 13 oxygens. And then you have 3 nitrogens and 3 nitrogens. So, this not too horrible if you just remember the specific steps. First, you need to balance the non-hydrogens and non-oxygens. Then you balance the oxygens by adding waters to the opposite side. Then you balance the hydrogens by adding H pluses to the opposite side. And then add electrons to whatever side needs to be added to in order to, again, get rid of that additional pluses that all those hydrogens added. Please note the electrons are normally going to be added to the same side you've added the protons in order to balance these charges. So this is a balanced chemical reaction in an acidic solution. But say I ask the same question, I'm just going to change one word here, which kind of changes everything. But instead of acidic solution, I'm talking about a basic solution. So please note, none of my work changed. Only the word up there changed from acidic to basic. And so the reason for that is whenever you work this out, and the balanced chemical equation that we developed for our acidic solution contains H pluses. And if you're an acid, which by definition creates H pluses or needs H pluses or contains H pluses, that's fine. But the issue is bases do not contain H pluses. And so in order for this to be a basic balanced equation, we need to get rid of those H pluses and have more of our OH minuses. And so the way that we kind of convert this from an acidic solution to a basic solution is for every H plus that you have, and again, you need to do the acidic solution steps first before you can do the basic solution. But as soon as you've created the acidic solution balanced reaction, you're going to add 1 OH minus for every H plus that exists. But please note, you do this to both sides. And the reason for it is because you have plenty of OHs floating around base. And so for every H plus that you have on your acidic balanced equation, you're going to add 1 OH minus on both sides. Please notice here, they're in purple, added to the reactant side as well as the product side. The great thing about this, and again, going back to your early Gen Chem year or days, is if you have 5 OHs and 5 OH minus aqueous and 5 H plus aqueous, we know by definition we end up with water. And so here you can simplify this by saying 5 waters in place of all those OH minus and H plus. And so the additional thing is, please notice on my product side, I included those 5 OH minuses because those did not cancel out on the product side. The last step here is notice I have waters everywhere now. And so you can actually cancel out whatever waters you have kind of going into this issue. And so here we have 5 H2O as a reactant, and we have 4 H2O as a product. And so 4 of those H2Os can cancel on both sides, and so you're left with 1 H2O on the left side or the reactant side. So throw all this into a very neat kind of reaction, and now you're looking at the difference between an acidic balanced reaction and a basic balanced reaction. And so for this one, please notice it contains OH minus and not H plus.